Hey everyone, Evan Kirstel here with a great discussion. We are live from Helsinki, Finland with Everynet to manage, build, operate among the world's biggest low power wireless networks. Vitali, how are you?
Hi, I'm fine. How are you doing?
I'm doing really well. Summer in Helsinki is paradise. I hope you're starting to enjoy the change in the weather.
Yeah, that's happening right now. So we had some rains like last week, but it's really sunny today.
Oh, it's good times. Well, we're going to dive right in. I've been in the wireless industry for 30 years and always keen to talk about the latest and greatest technologies. And you are a player in the wireless space that many people, at least here in the US, haven't heard about. Maybe introduce yourself and Everynet.
So my name is Vitaly Kleben. I'm Chief Technical Officer at Everynet. I'm leading the R&D department of the Everynet that is located here in Finland. And I'm also responsible to keep and maintain, I think, one of the largest networks dedicated to IoT in the world.
That is phenomenal. So tell us about the genesis of Everynet and where you guys started and kind of where you are now.
Yeah. So the vision of Evernet started, I think, in 2000, maybe 14, when we participated in establishing a new telecommunication standard called LoRaWAN.
Hmm.
And the idea was the following. Like, if you take a look at the wireless telecommunications, historically, they have been moving towards higher and higher bandwidth. Like, you had 2G, 3G, like 4G, right? And 5G, maybe 6G soon. And, it started with music, streaming of music, and then video, and then 4K video, and then, 4K video in 3D. But when you think about the sensors and, the small devices that are used to sense different type of parameters like voltages, pressures, temperatures, and so on, they don't need 300 megabits per second. Okay, it's just, if you take a water meter, it's only reporting data maybe once a day. So it's just, several digits once per day. 300 megabits per second is just not needed. So what we have done is, we reduced the 300 megabits per second to, let's say, 300 bits per second, and exchanged this bandwidth into different characteristics of the device itself. And for example, devices are now low power, which means that you could connect the device to the internet and keep it connected, and just use, like, a battery, and power the device for like 5 to 10 years from this battery. And
Yeah,
and that,
very, very, very compelling use cases. And we've seen low power wireless in all kinds of applications in the industrial side, in healthcare, in the smart home. Um, and now not only are the devices increasingly low power, they're increasingly smarter.
exactly.
And so you talked to me about something called TinyML. I wasn't familiar with the buzzword, the acronym. So maybe talk about what happens when devices get smarter and they meet this incredible low power wireless network you built.
Okay, so assume you want to build a device that is at the same time low power and smart enough to recognize some sort of complicated pattern. Probably, if I say TinyML, the I think that the best example of TinyML is the recognition of a key phrase like "OK Google,"
Hmm.
right? So it's a complicated problem to recognize this trigger word, and at the same time, the device needs to be low powered, because you don't want it to constantly, listen and draw power from your battery. So it just happened that the computational efficiency of microcontrollers and devices has been increasing exponentially,
Hmm.
while at the same time, the efficiency of data transmission is not increasing exponentially in terms of power, right?
Hmm.
So data transfer is basically expensive, and it's expensive. And to avoid that, TinyML has been basically introduced. And the idea is super simple. We train machine learning models on the bigger computers, but we evaluate these models on the microcontrollers or smaller devices.
Yeah, that's a really incredible idea concept. And what's behind the market drivers or the use cases behind TinyML beyond being an interesting concept? There's some real needs, some real opportunities.
Yeah. So um, I think starting from 2010, when the neural networks and deep learning really made a breakthrough. So what's happening is the compute that is associated with the machine learning is doubling every 6 months. So every 6 months. And everything around the world has been digitalized. It all started probably with the stock market, and then, e-commerce, real estate, like everything, except probably one untouched field right now. And this field, it is about the infrastructure that is built around human population: pipelines, roads, tunnels, grids, and so on. So what was required to digitalize this area is basically a low cost, low power devices that could be used to retrofit an existing infrastructure because it cannot be rebuilt, right? So, I mean, you cannot rebuild the London sewage system, for example, right?
Right,
So
right.
you need to retrofit it, and in order to do this, the technology, is required. And I think TinyML plus low power technology, this is kind of a magic combo that could solve this problem.
Yeah, so, and simple sensors, like you see today off the shelf, they're not enough to handle these kind of use cases. What is it about the requirements that are
Yeah.
becoming so complex?
Yeah. So for many use cases, they are actually enough.
Hmm.
So for many use cases, they are enough.
The,
But there
the
are
the the
some,
smart meter you mentioned, I imagine that's
yeah, like,
something widely deployed over LoRa
yeah.
networks.
So I have a couple of examples of the use cases that I like. Of course, people are doing smart meters, but they are kind of a little bit boring. But for example, there is this incredible problem that we're trying to solve. It is about the returnable packaging for different type of COVID vaccines.
Mm.
So we have to monitor the temperature of the vaccines in a box, but we also need to make sure that the boxes are distributed kind of in a right way. That, for example, there are enough boxes in the logistics centers, because sometimes it happens that all of the boxes are in the clinics, so they don't have boxes to ship, out the vaccines. So, and all kinds of interesting use cases. There is a use case for the construction industry where the company is providing specific sensors that are casted into the concrete. So it tells construction company when it's time to remove the foreign work and when it's time to paint the concrete or apply some coating on the concrete. And it saves up to 20% of construction time, because it's
Mm.
removing the safety gap. So, and but sometimes, in many cases, these simple sensors are not enough. For example, if you wanna detect anomalies in vibration, vibration sensors could be used to monitor AC units or refrigerators, like anything, any motor or compressor that vibrates. and it is impossible to stream all of this data to the cloud. So you end up with a small sensor that is constantly listening to a keyword, but it's not a key. It's not okay Google, but it's something else, right? So it's
Hmm.
some problem with the compressor vibration or something like this. And once it's detected, it's sending a signal that the anomaly was detected. And this is exactly where you want to use this TinyML approach to uh, to make sure that you could actually build the sensor.
Interesting. It looks like TinyML is an open community, open source foundation, and I imagine the power of developers bringing in their ideas and concepts and designs. That is really going to open up just a world of opportunity. I see there's even an in-person event in Amsterdam coming up. Is that the big idea as well?
Yeah. So TinyML is an open community. It has it is structured like a number of committees inside or work groups. I'm part of the TinyML deployment work group, where we collect the best practices on how to deploy and operate TinyML devices at scale. And but there are different many different work groups, such as on-device learning, for example, such as hardware, new types of hardware, accelerators, for example, for machine learning and so on. And but the ecosystem is completely open, and there are a lot of people from academia, there are a lot of people from the industry, chip makers, solution providers, a very vibrant and nice community.
Oh, it sounds amazing. I can't wait to check out the community. It's funny in this world of excitement about large language models, you're going in the opposite direction with TinyML. So the irony is really interesting. Well, let's switch back to the network because to take advantage of all of these new devices and sensors and apps, you need a great network. So describe what you're building, what you've built at Everynet, and I even have a slide here that might share some insights. Maybe you could describe what we're looking at.
Yeah. So Everynet works with the tower companies to build and operate large scale networks. And currently, we work with the tower companies in Brazil, Indonesia, UK and Ireland, United States, Iceland, Andorra, Italy, and Spain.
Well,
So
you haven't set too much ambition out there. That's a lot of networks, a lot of countries.
yeah, so and these are kind of large scale networks. I I think that in the United States we cover almost 600 cities. Yeah, it's here 550 cities. In Brazil, we cover like almost 70%, maybe even more now of GDP. So these networks, the scale of the coverage that we have at the moment allows us to build all kinds of projects that require either a huge coverage for logistics purposes, for example, or require a deep indoor coverage for example, smart metering applications where we need to densify the networks in order to deliver some SLA on device readings for our customers.
Fantastic. And of course, you're building your network on standards-based platforms. LoRa is a well-known
Yeah.
standard, but there are other standards, of course, in the 5G, 3GPP world and other proprietary wireless networking standards. What
Yes.
makes LoRaWAN uh, different and better differentiated from, for example, 5G?
Yeah. So I think what makes LoRa different is actually an open ecosystem of device manufacturers and solution providers. This is one of the key differentiators. But at the same time, I would say that the deployment model that exists with LoRa is much. better suitable for the densification. Like, if everything works okay, it doesn't matter which standard to use.
Mm,
But if something is not working and you want to densify, it is almost impossible to densify, let's say, a 4G network, right? Because you would have to have a fiber backhaul, you would have to have, a lot of
mm,
infrastructure that is needed around the base station, while let's say LoRaWAN base station is a relatively simple piece of hardware. And for example, Everynet provides a network extension service where we either deploy additional base stations for our customers, or in some cases, when we don't have a readily available infrastructure, for example, for smart farming, we don't have towers there because no one has
mm.
towers, right? So, but in this case, we just give gateways, we provide gateways to the end customers so they could deploy these gateways, these base stations on their own infrastructure.
Fantastic. So going back to TinyML, I understand you guys obviously know how to build and scale networks, but how do you build, scale, deploy TinyML models? Is there like an ML ops approach, and what's the best practices there?
Well, there are very few best practices right now. So TinyML is something that is very, very kind of young in terms of, let's say, operational maturity. So because 99% of efforts has been used to actually train the models, right? So how to train the model, that was the main question, like for years. And now we actually have approaches on how to do this, how to verify these models, and we are only starting our journey in on how to deploy the models and what would be the model life cycle and so on. So not too many best practices, but I must say that the complexity of this thing is because you have two cycles that needs to live together. The first one is the IoT cycle,
Hmm.
like which devices you have in a field, what is the hardware version, what is the software version, what is the like all of that kind of stuff. And at the same time, you have a model life cycle that needs to be blended with this IoT uh, life cycle as well. And this is the main complexity that we are trying to solve for.
Fantastic. So you're collecting a lot of data. I mean, you sensors everywhere,
Yep.
a lot of useful data. What happens next? How do you utilize all that data? Is that where things like large language models and other approaches to data science and data and analytics come into play?
Well, yes. My bigger vision for this is, uh, as we all know, the large language models like ChatGPT, for example. There are attempts to have like plugins for it, so it could, for example, search internet or do stuff like this, right? But in our case, I think what we are building is we are building an artificial sensory neural system
Mm.
for the large language model. It's not a body yet, but it is the way for the large language model, for example, to take a look at your smart city, right, and suggest something. Let's say, okay, what do I do next? Like, well, would you suggest like additional lighting or maybe rewire something or whatever? So I think that by connecting the information about infrastructure into the large language model, you could get a very good, let's say, smart city assistant, or you could get a very good some field infrastructure engineer, right?
Well, that's exciting. Very practical. I love the utility, no pun intended, usefulness of it, and a little more useful for society than creating funny cat videos with LLMs. But that's a, a whole nother
And
discussion.
like, to be honest, so I could work remotely. You could probably
Yeah,
work remotely as well. But there are many, many men and women, you know, in this country that are busy with keeping all of this infrastructure alive, right? And then we cannot live without them. So, and the infrastructure is enormously big. So, and
yeah,
I just want to give them a chance to work remotely as well, right?
yeah,
And to be more
absolutely.
efficient.
Yeah, there's so many opportunities, particularly I can only imagine around sustainability and climate action. You know,
Yeah.
we could have a whole nother discussion just on that. Um, so, how can people get involved, either directly with Everynet or through TinyML? I see you have an event coming up in the summer. Maybe talk about how folks can get engaged with you or your ecosystem.
Yeah, I think it's going to be streamed either on YouTube or LinkedIn, right? So
Hmm.
you could find me in LinkedIn and engage with me directly, and I would connect you with the right people in either Everynet or LoRa Alliance or the TinyML community. So feel
Mm,
free to contact me and tell me about yourself and what do you think, how do you think you want to contribute. If you don't know how to contribute, just contact me and we could discuss it.
fantastic. Well, thanks so much for spending time with us and the audience here. Any interesting summer plans? In the land of a thousand lakes in Finland, I imagine there's some fun outdoor activities coming
So
up for you and
yeah,
family.
we have like Southern Lake and one sea. So and my friend got a boat and it's an old one,
Oh,
and
nice.
I'm helping him with the diesel engine. So because it
Okay.
needs like renovation. So this is my plan for this summer.
All right. Well, send us some pics of you on the water. Enjoy the summer and congrats on all the amazing work. It really is
Thank you very much.
going to generate some tremendous opportunities and change for good. All right, everyone. Thanks for watching.
Bye bye.
Until then.